Hey, how you going? Welcome. My name is Michael Walmsley, as Matt said. I'm a serverless architect at Accenture. I'm also a serverless AWS community builder. I joined the AWS community builder last October. It's been an amazing ride. Everything that Matt said is true. You get to meet a lot of like-minded people. You get to collaborate globally with people in the same arena and share information, share blogs. I've met a lot of people. I'm still meeting more people. Couldn't believe I could meet more people. You can find me on Twitter at Walmsley. I'm on LinkedIn, and I've also got a blog at blog.walmsley.io. I'm very heavily into AWS, very heavily into Lambda, as you can see from my t-shirt. And I'm going to talk to you tonight. So my job is not just being a serverless architect. So I design systems at Accenture that run on AWS Serverless. I also teach people how to build responsibly on serverless, and I do a little bit of serverless enablement, which is kind of a perfect segue when I talk about serverless enablement into the topic we're going to talk about tonight, which is what I love about AWS Lambda PowerTools for Python. Who is doing any development today on serverless? Is anybody? People today? How many people do, what's the language? Python? Type Node.js, TypeScript, JavaScript, or just generally Node? C#? Java. Java's very popular. That's all right. What I'm going to talk about, I'm going to talk about what AWS Lambda PowerTools represents tonight, and there's a few interesting things right at the end I think will get people excited, so do tune in, even though it's very, very Python heavy. We're going to be showing Python code. We're going to talk about features. So I'm going to talk a little bit about how people get started with serverless, about how we all start with serverless, how I started with serverless. We're going to talk about a well-architected serverless lens, and that's really important. It's well-architected for AWS. We're going to introduce the Power Tools. We're going to talk about logging, tracing. We're going to talk about improved developer experience, because with serverless, improved developer experience is what we're looking for. It's what everyone is searching for, in my view, from the communities that I run at the moment. And then we're going to talk about quick and simple best practice. And if I'm going to hone in on one thing that AWS Lambda PowerTools gives us, it's that last one. It's the last two things, really. Improved developer experience and quick and simple best practice, which really comes from some really cool logging and tracing stuff. And I'm going to talk through what happens with Python. So that's what we're going to talk about tonight. We'll see how far we go. So when we start with serverless, this is how we start. This is how everyone started. Look on the AWS docs, look up SQS or SNS. How do I deal with that? This is what you get presented with. This is how we start. This is how we're taught by AWS to write Lambda. Is that how we all started? Did everyone else do that? I did that. You're nodding. That's how we start, which is really problematic. We process a whole lot of records, we print a test, we just print some stuff out, and we do some processing, and then we print out some stuff at the end, or we do something else. That's pretty much what we're trying to do. Many, even more people in my experience working with new teams on serverless actually start like this. Record equals event, record 0. Let's process the first element of my array and carry on. Now that's cool if you're dealing with SNS. But if you're dealing with SQS, by default with most frameworks, you're getting 10 records at a time. So actually, you're only processing one, you're losing 9 records. That's what 90% of developers that I've started with, that's what they write, because that's what they see. So that's why serverless enablement is really important. That's why I bring this one up, because this is really important. Really important to understand. So let's go back to well-architected. Let's come back to what I'm talking about tonight. Well-architected is really important. If we look at where AWS Lambda PowerTools came from, it came from the experience of Atalessa, who's in Europe. He actually started the PowerTools library for Python. Through his experience of writing and being a co-writer of the serverless lens of the well-architected framework, and he was working with clients, and he was understanding that clients were struggling with each of the tenets about the operational excellence, your security, reliability, performance efficiency, cost optimization. All of these things are what AWS say you should be doing with the solutions. And all these things, when you get started with serverless, is not easy. We know it's not easy. I know it's not easy. Because serverless is still new, and we're still struggling to find what best practice is. I think a really good person I've met recently, Paul Swale, who does a lot of blogging at serverlessfirst.com. He doesn't like to talk about best practice. He likes to talk about, I've forgotten the words now. Completely lost the word. He doesn't like to talk about best practice. He likes to talk about things that teams want to do. Like, best practice, not necessarily best practice, It's really the practice you have in your team that makes sense for the project you're building. And that's what Paul Swale talks about. And I think that's a really good differentiator. I think we need to stop as a group and a community searching for serverless best practice. Sure, there should be some. They take a long time to come through in reality. We've been doing servers for a very, very long time. We're still working on best practice for servers. Hopefully we've nailed it by now that we've gone beyond. But I like to bring that back to, let's not talk about best practice. Let's work about what works best for us and our teams. Because we're doing this. That's what we're doing. And that's why we need to think about well-architected, and we need to think about, well, how can we make those things easy to do? If we make those things easy to do, getting teams started with serverless doesn't start here. And that's what we want to stop. And that's what AWS Lambda PowerTools is going to give to you. It's going to provide, it's been out since 2019. It's a great open source library, generally available in 2020. The core tenets are really interesting. It's for AWS Lambda only. So it's AWS specific. It's built around the well-architected framework. It's all about, this is directly off the website. It's easing the adoption of best practices. They want to keep the framework lean. They want to strive for backward compatibility. And they want to work backward from the community. So give the features to the community that the community are after and want. And the other important thing is, everything I present tonight is progressive. You can progressively adopt each of the strategies. You don't have to go all in. You can start small. You can start with the things that make sense for you to improve your workflow. And I think that's what really the basis of what I'm really excited about with AWS Lambda PowerTools. As a first examples, logging and tracing, we should all know that logging and tracing is not just a print statement. It's not a console.log. We really should be doing structured logging. Yeah? Everyone's nodding? Everyone doing structured logging? We're all doing structured logging? I hope we are. Structured logging is awesome. And I'm really keen to do a more detailed deep dive into structured logging one day. Out of the box, this is what PowerTools gives you. 0 work, 2 lines of code, 3 lines of code. Ability to inject custom fields, simple to use, consistent, and it's really simple to get X-ray tracing working. X-ray tracing is getting tracing working with X-ray, getting subsegments and all the things. You got to work through the SDK. Adding logging, really, really simple. Import it, create it, add a decorator. We're dealing with Python here. Python loves decorators. Decorators are powerful. It's like middleware. If anyone's ever used middleware or done composition with Node or TypeScript, you can do composition of your functions, which is pretty much middleware. That's what this is. And it becomes really clean. We basically take the logger. This is saying, inject the Lambda context, which is going to give me the function ARN, give me the line of the function, a few other details. And I've said log event equals true. Don't do that in production. That's going to log the event for you automatically because it's middleware. So it's a feature that gives you a debugging capability. It's really, really simple. And that can actually be turned on and off with an environment variable. But very simply, we've now taken our original code we saw on slide 1, and we've kind of improved a bit. We don't only have prints, we've got logger.info. So we're actually getting real log information. We're getting that with other fields. We're getting context. We're getting other information we can search for, which is really, really powerful when we talk about logging, traceability, observability. Adding tracing. We talk about the tracer. What does the tracer do? Like the tracer just gives us exactly the same thing. Tracer, it allows us to capture the Lambda handler. It gives us a subsegment. When that executes, it'll break down the cold start. It'll tell us how long things are taking. It'll auto-instrument the AWS SDK for you. It'll give you a rundown and breakdown of how long every SDK call takes with just 2 lines of code, which is awesome. I think it's awesome. That's what I love about it. And even more than that, you can add method subsegments. So you can capture the method. When you actually call functions, now you can actually capture how long each of your functions are taking with just by adding a tracer capture method. It's really, really simple. It makes understanding what your code's doing and where it's spending time really, really, really simple. And I love that. Like those 2 things alone, I love. Those 2 things alone, I think provide a lot of safety for teams in developing with AWS and Lambda because it stops all those mistakes. Let's go a little bit further. There's a lot more that it adds. I'm going to talk about event source data classes. If anyone's a Python head, don't think data classes in Python. They're actually event source data classes. That's why I've called it that. They're not the same thing as doing @data class. I'm still learning about that. I'm not a Python expert. They provide, the tool and the open source library has really focused on documentation, being documentation first. So they really focus on Developer experience is a real part of the program. So type hinting, code completion, all those things when you start dragging the libraries in, they focus on. Helper functions for decoding, deserializing, nested fields, all that hard stuff. They add utilities to make it easy, to make it simple, to really break down the boiler code that we're actually building day to day. They've got really powerful doc strings for fields. They allow you to choose what you want to use. That's coming back to the first point early on. You can choose what you need from PowerTools. So you can start, just grab the logger, grab the tracer. Instantly, I've improved the quality of what I'm producing and what I'm doing with my solution. And every utility and feature that I'm going to talk about tonight is completely optional. You can choose to adopt it if it makes sense for what you're developing. So you can actually choose that, which is awesome. So there's no lock-in features. Talking about data classes, what we're talking about is really quick classes that we can actually cast the event to give us in IDE hinting, type hinting for all of our events. How many people struggle with Lambda in understanding what's the event that I'm going to consume? Right? That's the number one thing I think I've ever tried to Google is what does the events look like? More often than not, what I actually do is actually push the Lambda up, set up the trigger, and actually just log the event to see what it looks like. Because they're documented in the AWS website, but I'm not sure how accurate that is sometimes. I think it lags a little bit behind sometimes. I think it's getting better. But having these quick casts, the team, the community behind PowerTools works really hard to keep these up to date and keep these relevant for all developers, which is cool. They're easy to use. Again, no overheads. And IDE typing team. I love that. That's what I love about Lambda PowerTools. When we talk about event sources, we can even go a little bit further. So we've got the classes that you can cast to. There's also a special decorator called event sources. And once you define an event source, you can tell the event source, you can tell PowerTools what data class I'm expecting. And now it'll inject an object for you. You're not dealing with an event dictionary. You're actually getting a class, an object, instantiated, injected into your code. So now you have something real. That doesn't necessarily have to be an event representing an AWS event. That could be a custom event. It could be a custom event for your API representing a user, representing a business object. So now you can actually start abstracting your code away from the cloud and actually start building an application and actually have application developers who don't need to know about the cloud anymore because you're abstracting that away with something with frameworks and tools and utilities that PowerTools can offer you to make that really simple and fast to do. Quick and simple best practice. Dedicated handler. This is one of the cool things I like about that the team has done is they've produced some really cool handlers for a lot of the use cases out there today for what you're building. One of these is the API Gateway Resolver. How many people have built an API for a REST API? How many people have then built one for a HTTP API? Or who wanted then to go into an ALB? Or maybe that's not working for them. Maybe they want to use the new function URLs instead. The beauty of something like the API Gateway Resolver, think of it like Flask for AWS. It's a very lightweight router for APIs, right? The beauty of this is the API Gateway Resolver locks up the event type that's pushing it. So it could be AppSync, it could be REST, HTTP, ALB, any of those. You can have exactly the same code executing with different triggers just by switching out the core class that is used by the Gateway Resolver when you instantiate that. It becomes really easy. It locks away all that boilerplate and makes it simple. When we talk about the 80% use case, supports cores. When we build APIs in the cloud, generally we're dealing with the front end, right? What's the number one pain for developers? Cross-origin resource sharing. I'm sure everyone's had this. Everyone hates it. It's the front end goes, it's not working. And it's always cross-origin resource sharing, right? So that's out of the box. One line of code, configured. Really, really simple. Again, going to that 80% use case of making the boilerplate really, really simple. Integrates with data classes, so you can actually have custom classes. Supports dynamic path expressions for correlating IDs. All sorts of fancy stuff. It's really easy to use. I love it. It's like Flask for Python, like I said. like I said. And the team works really hard with the processes they have at build time. Every build they do, they measure the overhead of the code to ensure that the routing code for the API is as small as possible. And they have thresholds that they will refuse to release if it goes over, which is really cool. So we've got some really good processes involved. So example of Gateway REST Resolver is basically just setting it up. And then we just do add-app.get /hello. If I hit /hello on my API, I've got the resolve down here in my Lambda handler. It's now deferring all of the API calls up here if I was to proxy it. I don't have to proxy it. I could actually do /hello to call that and it'll be fine. It will work. So you can use this as a convenience method of launching your code and getting a standard structure to really accelerate how teams work and how teams can work. And that's probably a very controversial case when we talk about APIs. There's a lot of people who go, the Lambda should be triggered by the gateway. So I like using this because it abstracts a few things, right? Even if I've only got a single use function, you can still have a single use function, but now you can abstract it away. You can actually pivot to an A or B if you need to. You can pivot to a function URL if you need to. You can pivot to a HTTP. You can pivot to AppSync. You can pivot to all the different invocation methods for an API that AWS offers. And going back through dedicated handlers, one of the most powerful things in the dedicated handlers, a lot of work we do is dealing with streams of data. So we talk about SQS, Kinesis, DynamoDB streams. These are all we do with batches of data. So this is kind of the execute model where we're executing through, an AWS poller that's pushing us a batch of records. The batch processing utility that's been built into PowerTools abstracts that away. It makes it really, really simple to use. It automatically kicks in and does the batch item failures for you. It'll automatically send the failed items back to the SQS queue using the new feature which was released late last year through the SQS. It also integrates with event data source classes. And if you want, you can actually build your own because they've built primitive classes within PowerTools. So if you've got a custom use case or a custom batch processing use case, you can wrap that up and build that bespoke to hide all the complexity away from application developers, which I think is really powerful. So even though they're producing utilities, they're giving you the option to break out of that model if you need to. So batch processing is really, really simple to use. You just instantiate that guy, tell it what the event type is, and down here at the bottom, you do your processor, you return your processor.response. And if I go right into here, tell it the event type, we do it the batch processor, we tell it what the function to call through the record handler. We tell it what function needs to call for the batch, and it will go and process that. And it will automatically, through that batch processor, go and deal with every record. And the beauty of that is your function code no longer needs a loop because we're getting one record at a time. So actually your function code is simpler, which simplifies what you write. Less code is good code. That's what I say. Every line of code is technical debt. That's my mantra to development teams these days. They don't like it, but here we are in the serverless world, managed services. We should be writing less code. So when you do need to write code, this is cool because it actually lets you write less code. If you use somebody else's code, that's awesome. I love other people's code, as long as it's tested. And again, we're not doing this anymore. I mean, how far have we come? The code becomes more readable. It's easy to understand. Idempotency. If you ever have a problem in the cloud, 9 times out of 10, it's probably going to be idempotency. If you ring up AWS support and go, I've got a problem with my SQS queue processing, you know the first question they're going to ask you? Is your solution idempotent? Does anyone know what that means? Everyone's nodding. I need to do a session on idempotency. It's interesting. Very interesting. It's critical. We need that. It's critical. And idempotency is not easy. It's not easy. I recommend going and reading this article from the AWS Builders Library, Architectural Library, Making Retries Safe with Idempotent APIs. Best article I've ever read about idempotency. I read that article when I was writing a blog about PowerTools idempotency utility late last year, when I started blogging for community builders, or for community builders. Forget, it's all a blur. But he talks really interestingly about idempotency as a method of simplifying client interactions with API, simplifying client code. Because at the end of the day, if anyone watched reInvent last year and saw Dr. Werner Vogel's keynote, he talked a lot about what they've learned about APIs in the last 15 years. And they talk a lot about simplifying client interactions. And I think that's a really good, I think if anyone's writing APIs out there, go and watch it. Absolutely go and watch it. It's awesome. The beauty of this, if you properly implement idempotency and you simplify your client interactions, it becomes safe to retry. Simplifies your code, simplifies your handling, and selling it here. I'm kind of a salesman now. AWS Lambda PowerTools has you back here. They've actually built an idempotency utility. Now this was built by AWS engineers predominantly. So there's a lot of AWS experience have gone into all the different use cases around idempotency that you'll come across. It's basically out of the box with a little bit of config, a little bit of configuration, but you can also choose how you store the records that need to be stored. So the idea of here with idempotency is if I run a post into my idempotent API and then I time out, my client times out, I can retry that, and I retry exactly the same transaction again. My API will go, nope, sorry, that's in flight, and give me an error, or give me a particular response to go, you can actually retry that later. If it completed, it'll actually give me the exact same response that it already tried to deliver that I never got. And that's what idempotency, true idempotency will deliver for you. And the utility inside PowerTools is super powerful. It does a lot of features. But again, utilizing this guy, set up your persistence layer, instantiate your configuration, and then add the decorator. And that decorator takes care of idempotency. Now here we're talking about idempotency on a handler. It's not just for handlers. You can do it on a function. Idempotency is available on any function within your code. That, from an SQS queue processing perspective, combining batch processing with idempotency, now you've combined two key problems that we have to deal with when we're dealing with stream processing. We've now got idempotency. This idempotent function won't call twice based on these keyword arguments and configuration I pass in. It won't double process a record for my batch, because we all know the SQS, if we're dealing with the standard SQS, at least once delivery, right? Right? At least once. 1 in 10 million, you're going to get more than those. Right? It's not going to work all the time, because the cloud doesn't work all the time. It will deliver on the promise, which is at least once delivery. So this guy with the idempotent function actually enables out of the box with very, very little minimal configuration and setup in a simple environment. I'm sure this can get more complex. Questions at the end? Can we talk about that after the session? I think we'll take that offline. There's a lot to talk about. Yeah, probably could. I actually did a talk at Accenture. Accenture, I do a weekly or bi-weekly talk about serverless. I actually spoke for a whole hour on idempotency, and actually to get it across the line. But there's heaps more, and these are things I haven't really covered. There's metrics, so custom metrics via EMF, so the embedded metric format that goes in the CloudWatch. That's amazing. $0 to send you metrics. Sure, it's going to cost to consume, to view them at the other end, but pushing them out the CloudWatch makes it a very cheap mechanism. You're not paying for the API calls to create those metrics. Don't quote me on that. If you get billed, don't quote me on that. There's also built-in JSON schema validation out of the box. You've got that available. There's model parsing for Python using Pydantic. There's a really neat parameters and configuration setup that will automatically cache parameters from parameter store or configuration from app config. So you don't necessarily need to use layers, but out of the box, it will cache this stuff for you, which is amazing, right? It makes it really, really simple to use. There's been some other features that have been developed by other community members. Feature flags from a guy in Israel called Ran Eisenberg. He produced a really, really fully featured feature flag, runtime feature flags for Python PowerCode. GraphQL throws up, and exciting thing for me, I'm going to finish up here, is not just Python, it's Java. Java originally was where it started with AWS Lambda PowerTools. Came to Python. TypeScript is currently in development. Logger and Tracer metrics are coming out. Release candidate is end of July, end of this month. That should be out. And .NET is currently on the roadmap and being worked on. So check out the roadmap. Go and have a look. For that, in summary, is what I love about Lambda PowerTools for Python. That's not just for Python anymore. It's for everything. Thank you for joining. Yeah, questions? So idempotency. So the question is about idempotency, about, well, what does happen? What does PowerTools do behind the scenes? Behind the scenes, when you configure the idempotency utility, you're going to configure particular parameters inside your event source that represent the fact that this is what uniquely identifies that transaction. What it does is it will store that into the persistent store, whether it's DynamoDB, Redis, or other store. And next time a transaction comes in, the idempotency utility will go and check the data store at the status of that. And part of that data store is if that API completes and that process transaction completes, when the response goes through the idempotency decorator, it'll take that response and store the entire response into the data store. So if you get a repeat transaction, what you actually do is you actually get a successful response again. So the idea of idempotency is that if I go and do a post to a transaction to store something in a database with my API, and I don't get a response, but I retry that, if it's idempotent, I'm not going to end up with 2 records. I'm going to end up with 1 record. But the beauty of that is if it already completed, I'd get exactly the same response that came through the first time from the first transaction. And that's what the utility is doing. It's true to the letter of the builder's library reference that I marked there. Yeah. Yeah, by default DynamoDB, but be wary if you do, because 410 kilobytes. Up the back. Wasn't a video, there's a link. Oh, I spoke last year for an hour about idempotency at Accenture. I work at Accenture, do serverless enablement. No, not specifically, no. It's a link to the architectural library at AWS, the builders libraries. And it's a really good article that describes idempotency very clearly. But yeah, sorry. I must co-validate my brain. No, I do. Yeah, so I guess that's not really pertinent to the topic I talked about tonight, but generally, you know, testing is still relevant. You know, unit testing is still relevant. So if you're unit testing your functions, that's really